Alright. Okay, hey, let's put all the computers away, all notes, everything like that. Okay, alright, now the test I'm going to hand out. I want them back. You're not going to keep them, they're mine. Definitely turn them back in after we're done, so don't crumble them up, don't do anything like that. We're going to go over the test scores so you can see what I missed. Now, if I make a mistake, and I counted something wrong when it should have been right, because maybe I made a mistake and I was going too fast, I'll give you the points back. But if you got a freebie, that's your freebie. So I try to go through kind of meticulously to make sure I don't make mistakes. It could come down to just a difference, like if you're comparing yours to a neighbor, it could come down to a difference of like a plus or minus sign, why you missed an extra point than somebody else did. That does happen, and that really always upsets people. They look at their answer like, Ward, we have the same answer. It might come down to just a plus or minus sign. It could be an extra point. So keep that in mind. That always throws people off, and they always get mad. Answer's wrong. So, all right.
Oh yeah.
You're so light.
Irish summer, I a lot of music.
You forgot the band. Otherwise, you're local.
Alright.
Is that a different arm, Joe?
What?
Wait, what'd you say?
You need a band.
Oh, bandana. Unless you said band-aid. Different
No, actually.
Give a Ward, can I retake? 47 out of 50. I never had a 4.0.
Trying to decide.
I should mention that.
Alright.
But I missed a review.
Alright, did everyone get their test back? Did I forget anybody? I think everyone's got it. Alright, now remember, I'm collecting these back here in about a minute, or after we go through all the test questions anyway.
Hey Ward,
Okay.
can I come in tomorrow morning?
Yep, you can always take a retake. Now, here's the thing I want to warn you of. If you're going to take a retake, I give you the better of the two scores, so no matter what, it's a no-risk gamble. Now, here's the thing. You only have 1 week from today if you're going to retake it. That doesn't mean come in next Monday and go, Ward, I'm going to review it today and take it after school. That doesn't happen. So next Monday is the last day you can retake it. You're not coming in reviewing that day and taking it at the same time. So you have to review it this week, and then the last day you can take it is next Monday. Now, here's what I recommend. Come in as soon as possible. Start reviewing with me tomorrow morning, today after school, whatever you need to do. And then at some point we schedule you this week to retake it. I prefer not to retake on Friday afternoon, like after school, because we have that pep rally. And I have to set up for the homecoming dance right after that. So I prefer not that day. So you have select few days you can retake this. Do not wait till next Monday because you'll start to forget stuff. The only thing you'll get when you retake it, I will have a separate sheet of paper that will have Pascal's triangle on it. But remember, the problems will look different, right? I'm picking different problems out of the book that are the same type. So they'll have different numbers. Don't just memorize your answers here. Okay? All right. But again, it's better than two scores, but you have 1 week to retake if you're going to do it. All right, now, let's go through the actual test questions. Okay, I'm going to wait for it to get quieter.
Not like long, like beaver hair, I got
All right. Okay, let's walk through these all together so you can kind of see why you missed it, what the points were, all the good stuff. First one's out of 4 points. Okay, all you have to do is plug in the 8. 8 minus 6 is 2. 2 to the third power is 8. 8 times 5, because you have to do the order of operations, right? Parentheses, exponents, multiply. 5 times 8 is 40. 40 plus 6 is 46. I did have somebody that attempted to do it with Pascal's triangle. Well, I mean, the math was somewhat correct. The problem is they didn't finish it because they didn't have the plus or minus signs right. What I mean by that, you can do Pascal's triangle with this. I know that's absolutely ballistic, but you could do it because you could set up the 8 in there, so 8 minus 6, and it's power 3. You could do this parenthesis as Pascal's triangle, the 1, 3, 3, 1. The numbers you'd have is 8 times a negative 6, 8 times a negative 6, and you could go through all of that and do that whole Pascal's triangle. These numbers are absolutely massive, and the thing is there's plus and minus signs in here, and they would all, add and subtract down until you get 8, which is 8 minus 6, which is 2 to the third power. So, and then you can take it times 5 and add 6. You could do that, and I saw somebody attempting it. They just didn't finish it. Which, I was a brave person who ever tried it. Alright, moving on. Alright, moving on. Okay. Number 2. Alright, intersection. Intersection. There's no numbers that they have in common. It's literally an empty set. I accepted some stuff that probably would be. I accepted some answers that would not be accepted in college. I had some people just put nothing, or they just left the bracket blank. Preferably, if you'd actually put null set or empty set, or you put little circles across. I accepted those because I understood what you were doing. There's nothing. There's no numbers that they have in common, so it's just an empty set. I understand that, but again, you got kind of lucky with that. Now, I had a bunch of people try to write down the numbers. That's a union. You need to write down all the different numbers that you see. Even if they're repeating, you don't need to put repeating numbers. Some people did. I just kind of crossed them out. You could do that. You don't need to. It's just 1, 2, 3, 4, and 5. That's a union. So, on tests, if you're going to retake, you got to know the difference in symbols, because I'm going to pick 2 different ones to put on the test. Okay, next one. So next one, number 4. People, I don't know what you were doing. Wasn't this type of math. All you have to do is distribute. Distribute the 4, distribute the negative sign, and then just add and subtract things together. I had people try to FOIL and do some really weird stuff. You're going overboard. It's just 20 minus the 6, you get 14y's, negative 12, and minus 3 more is negative 15. Okay, moving on. Next one. Negative 3 to the third power is a negative 27. It's negative 3 times negative 3 times negative 3, which is negative 27. This is negative because there's 3 of them. Then when you square it, a negative 27 times negative 27 is a positive 729. I had a lot of people putting negative here. I had some people got some really goofy numbers. I don't know what you're doing. Maybe you typed in something wrong in your calculator. Always, if you're typing stuff in your calculator, type it in 2 or 3 times to make sure you're getting the same number every time. Because calculators might have something pre-programmed into it, and you didn't know it was doing something behind the scene. Okay, number 6. Some really goofy answers here. I even warned you what to do when you took the test. You have to just distribute the power first. You can see I'm distributing the power of 2. I distribute the power of 3 through that next parenthesis. Then you just do the normal multiplying. 25 times negative 216. Negative 5,400. X's, there's 29 of them. Y's, there's 35 of them. The trick was you have to distribute the powers. I had some people doing some really weird stuff where you're taking the 5 times 6 and the X's and the Y's, and then the powers on the outside, they were adding them or multiplying them. That's not what you do. Order of operations, you should do exponents first, then multiply second. So, order of operations. All right, moving on. 7. Distribute the power. If you notice, I think this is almost the exact same answer to the one that we used on the practice test. And it was a negative 27 over something. So, you distribute the power of 3 to everything. Here you go. You can see me distribute the power of 3. This B goes to the top and makes 30 B's. The A's would cancel out and there'd be 9 of them left on the bottom. Easy peasy. Moving on. Okay, next page. Most common mistake people made. Not putting the decimal behind the first number, counting how many spaces you did wrong. It should be 10 to the 7th power. That is because, now if you look at the directions, it said proper scientific notation. Not just scientific notation, proper. That means it has to go behind the first number on the left. I warn you that a lot in the notes we've done. Next one. Next one. You move the decimal behind the 4, so it's negative 4.15. And then you had to move it back 4 spots, so it's negative 4. Okay, moving on.
And then 41.
10. Multiply them together. Most people got to the 12x to the third. But then they didn't go further. You have to break it up. This is me breaking up 12x to the third. I had pairs, I kicked them out. Here's your final answer.
So I am.
Okay, 11.
So I am.
Shh. 11. Divide the 500 by 10. Divide the, or x to the negative 1, move it up to make x to the negative 4. Here's the weird part. On practice test day, I wrote your problem on the board. And I said, this is an example that could be there. And I literally put the problem on the board. That one. So, to warn you what you need to do if there's negatives. So you moved it up, you got 50x to the 4th, you break it up into all my numbers here, I had a bunch of pairs, I kicked them out, and there's still a 2 left over. Let's go to number 12. To add and subtract those, don't tell me that's 42 x's. You have to break them up, and it is a cube root. So I have a bunch of 2's there, I have a bunch of 3's and a 2. I have triplets, I kick a triplet out, kick a triplet out. This makes 10, not 7. That was a common mistake people made. Every time you do radicals, it's always multiplying. So when the 2 leaves, it's multiplying on the outside. So that makes 10, this makes 3 on the outside because you're multiplying those together. Then when you subtract, you can get 7 in the final answer. But I had a lot of people, when they moved the 2 out, they said 7 root 2's, and they're getting really weird numbers. If you happen to forget a 3 on your radicals, that technically is wrong, I almost counted it off. So be careful of that. Okay, I might have, you made a bunch of mistakes there. 14, you have to multiply by the conjugate. You can see what I did there. I foiled the top, I distributed the bottom to everything here. The 15's canceled out. This is a 3, that's a 5. 5 minus 3 is 2. And if you wanted to, you can go further. You didn't have to. But if you went further, you better know what you're doing. Okay, moving on.
Oh, it's over 2. How do you get to 2?
5 minus 3.
Yeah, you serious?
5 times 5 is 25. 3 times 3 is 9. This makes a 3. That makes a 5. 5 minus 3 is 2.
Somehow I got 1.
Right?
Oh, I didn't foil. I just assumed it was 1.
Nope. Okay, moving on. All right, 15. Number 1 common mistake, and this blows my mind. People forgot to use degree.
I forgot to put degree and I even had it circled.
Yep. I even warned people, put degree on it. People circled it. It was number 1 in both classes. Number 1 question missed on the entire test was that one. Forgetting degree. It's degree 3. Now, you just heard the negative sign. You add and subtract like terms. You had 12 x's. You had 4x squares, 12 x's minus 14. The craziest answer I saw, somebody distributed the negative sign, and then they foiled that whole thing out. I had somebody do that. I even warned people that practice this, don't do that. The next thing that I saw that was crazy, that I saw was people did all this math, they distributed the negative sign, and then they got rid of all the powers, like all the x thirds, x squares, like all the powers are gone, and they combined all the x's. So they only had like a bunch of x's and then a number after it. And I think the number was 14, but then they had like all these x's combined, so it was 28 x's, but there's no power up, because they actually combined 12, 4, and a 12. That was like the craziest answer I think I saw, other than foiling, because that took forever, whoever did that. Next one, number 16.
Are they in here?
No, I don't think so. All right, number 16. Pascal's triangle. Pascal's triangle is on the board. That's why I went up through 4. You need to see 4. I even warned you of that when we were doing Pascal's triangle. Something to know. 1, 4, 6, 4, 1. I have my 5x. The most common mistake people made is they were like adding and subtracting these together. you always multiply the two terms together. They're always multiplied on the inside of the parentheses. Even if it's a plus or minus sign, they're being multiplied. So I think that's where some people are getting some like really smaller numbers. 6 to the 0 is the number 1, 5 to the 4th is 625, and then you multiply these together to get 625. And I think people were adding to get 626. Next one, 6 to the first power, 5 to the third, and a 4. You multiply those together to get 3,000. I think the goofiest answer I saw was somebody put like 131, they added these together, and then they took it times 4. So they got like 300 or something like that. Next one, 6 squared, 5 squared, and 6. You multiply those together to get 5,400, x squared. Next one, 6 to the third, 5 to the first, 4. You multiply those together. 6 to the 4th power, 5 to the 0, and then 5 to the 1. You multiply those together. And there's all of your answers, right? Again, the same person who made a mistake on number 15 made the same mistake on number 16 here, and they forgot all the powers and x's. And they combined them all, and their answer was just 1x and one number. They had this number right, but then their x's were all wrong. Okay, and it came down to just numbers. If you showed work and you accidentally did that thing where you added, I just counted a point off. Because some people forgot that they're adding these in. Simple mistake. So.
What about the person that combined all of them? How many times did you
1.
I think that times worth 5 or 6. No, it was worth 4. Because I was looking at how many things they had. Okay, 17. Hey, so 17, you had to pull out a common factor number 17. So 17. On this one I pulled out an x squared. On this one I pulled out a -2. So this is what I had left. I pulled out an x squared, and here's what I have left. Notice they have the x plus 6 is in common, so I pull that out. X squared minus 2. That could go further. I didn't require it because it wasn't a perfect square. So that's grouping method. You pull out a common factor for each term, and what's left is the thing that they also have in common. Now, 18. You had to pull out a greatest common factor. The greatest common factor they had was a 3 and a y squared. So when you pull it out, this is the part I already warned people of when we were doing homework on this. They always forget that there has to be a 1 here. Because you have to have a binomial, because the original thing's a binomial. This thing is a difference of squares. And I warned you, when you do common factors, you might have to go further on common factors, and that when you did, it was the difference of squares. Plus minus, 4 to 4, y and y, that type of thing. Alright, next one. Cube rule. Cube rule is cube root of that, cube root of this, signs in the middle. And then the idea is that, so the cube root of 64 is 4, the cube root of x is x. These two numbers make the back parenthesis. The most common mistake people made, the plus and minus signs were wrong. Common mistake. If you had a minus in the front, it should be plus plus. Because it's the opposite and then always positive in the back. The outside terms are made from these two things squared. The middle is made from just these multiplied together. The most common mistake that I saw, also other than plus minus signs, the cube root of 64, people put 8 because they're taking square roots, not cube root.
Yes.
Another goofy thing, I saw that people had the 4x here, and then they would triple that and put a 64 here. So they're just kind of doing some weird stuff. The one thing that I do not want to see ever was, I think I had 1 or 2 people do this. They took the cube root of this, the cube root of this, they put a minus, and then they went, oh, it's a cube rule. And that's their answer. That's not paying.
That seems smart to do.
So, here's how you know you did it right. Just multiply them back together and see if it turns out to be the original thing you start with. No one even attempted to do that, I don't think. So, alright, I'm going to walk around, I'm going to collect, they're mine. If you want to retake, you just come in before or after school, and you can go over. Now, again, if I made a mistake, I'll own that and I'll give you a point back if I made a major mistake.
Yeah, I think I got
Go back through?
Yeah. I think I might have done the extra.
Yes. Let me get it back.
Come on, I will hear it. That's why I always go back and make Allison, massive biceps are super attractive.
I know.
Like, can I do that?
Mine's fine.
Okay, alright, do I get everyone's test?
Have you seen her?
Wait, we're talking about massive biceps.
Also, Brenda Davis.
Her and like evidently
Or what?
don't say.
Yeah, she has one.
You're probably right about that too.
Nah, hey,
It's okay though.
it's gotta be it, right? Not it.
Alright.
You guys are pretty
I should have drilled all that's using Pascal. He just draw a person labeled as Pascal and put a triangle.
say he owns this.
That's it.
Thanks.
Garrett.
Alright. Okay. Let me get rid of this. Alright.
State engineer. You go to school to be an engineer?
I?
Yeah.
No. I was really contemplating it, but I went to go for teaching. I did. I just, because after I heard like what I would need to get engineering, I just needed a few more classes. Like, I'll attempt it, and I kind of took one course. I was like, nope, no.
It wasn't too hard then, but so you just didn't like it?
No, it was just kind of, okay. All right, so here's the main stuff I want to talk about. This week, we're gonna do some notes today. Tomorrow we'll probably get an assignment on it, which is a really straightforward assignment. It's looking at tables. It's looking at functions. I don't think there's any. I don't think no. There's a couple graphs, so I will give you graph paper tomorrow. We're gonna review that today. There's a couple graphs we're gonna talk about today. The idea of what we need to do. I won't actually show graphs until tomorrow. Okay, so we'll have a homework assignment tomorrow. Wednesday we'll probably intro the next section, and then I think I have you guys on Thursday, not Friday, but Thursday, and we'll just continue on that section. We might do like an in-class activity that day.
Work all week?
But
Or work all week? I thought we were just gonna do nothing in school all week.
no, yeah, no. Here's the idea. Once we're through that, our in-class activity on Thursday that we do will be for points. We'll do a couple things where it's easy points, just like participation kind of a thing. But you definitely want to take a bunch of notes that on Wednesday, because the stuff we're introducing is different. I don't know if you've ever done it in Algebra 2. It's not difficult. It isn't, because it's very simple rules that we just check and see, do we have this rule or not? So that's what we're going to be looking at, but there's a lot of them. So that's what we're going to look at. So kind of keep that in mind. Let's see. Next week, because I don't think I have you guys on Friday, but next week, remember, Monday's the last day if you want to retake a test. Monday's the last day you can actually retake it. Not review, but retake. So keep that in mind. I want you to review this week if you have time. Okay? Before or after school, I'm here all the time. But not Friday after school, because we have to set up for homecoming dance. Okay. All right. Is everyone good? Does everyone have everything out? Okay, there's two problems I want to write down on the board. That's it. Two problems. Here's number one. So here's what I'd like you to write down. Okay, we're going to discuss this. Part of our two topics I want to make sure of. -1, 0, 1, 2, and 3. Let's see. All right, here's the idea. I only want to do two things today. This is the first problem out of two. The second will be the next one. So, what you're looking at here is a table. The table has a bunch of x's, and it has two functions. It has a g function and an f function in no particular order. And the question that your book will ask is they're going to give you some data, and they're going to ask, maybe this is question number 30. It'll ask you for f of x is what function? So what I mean by that is they're going to give you a multiple choice, A, B, C, or D. And they're going to give you your function, and they're going to ask what it is. So it could be y equals x plus 1. It could be y equals 2x plus 1. It could be y equals 3x plus 1. Or it could be y equals x squared plus 1. Okay, and they're going to ask you which function is it. So it's an A, B, C, D, or E kind of a question. I don't know how many options I give you. So here's the idea. What I would do to check which one it is, if it's any of them, plug this number in and see if it's spitting out that answer. Because again, how I know that is they want you to check the F function, right? So that's why I'm going to the F column on that table. So when I look at these problems, if I took this times 3, that would be -3. Add a 1, that would be -2. Okay. Take this times 3, add a 1. Okay. Take this times 3, add a 1. So it looks like. Shh. So if I took it times 3, you'd get a +1. So it looks like in every single case there, letter C was the one. Now, you don't just pick the first one you notice. Guys, stop talking. Seriously, that group is really annoying me right now. So, all right. But you have to pick which one works in every single case for letter F. Not just the first one that you find that works here. It has to work for every single number down the row. Because it may work for 2 of them. You have to check if it works for all of them. So now, the next one. Maybe the second, number 31. Maybe it does the same question, but it asks for g of x. It has the same exact questions. Well, it could be, number 1, it could be the same exact formula. Obviously, it's probably not, because if you look at g up here, it's got different numbers, so it's probably not the same formula. But it could be, which one of the A, B, C, D, or E that it is. Well, the idea is that it's probably letter D. It's probably x squared plus 1. Here's how I know. If I square that, it makes positive, add a 1 to it. Square that, add a 1 to it. Square this, add a 1. Square that, add a 1. So it's letter D, right? It's that formula. And again, how I'm checking that? I'm plugging in the x's. Is it spitting out the right y value? When I plug in like the 3, when I plug in the 2, when I plug in the 1. Now that's the numbers I'm checking for. And again, they'll give you options. It's just that really confuses people when they first see it. They're like, I don't even know what to do. You have to plug in the x's, and will it spit out the right y number? And you're trying to figure out which formula represents it. Okay, does that make sense? The first question today. Okay, second question, second and final question today is this one. 3x squared plus x minus 1, and x is -3, -2, -1, 0, and 1. Okay, this is the second and final question that they're going to ask you to do. They're going to say, for the following function, graph it. So graph that following function. They don't want you to go and try to figure out all the rules that you did in algebra 2, and factor, and all that. No. They just want you to plug in the x values that they gave you, and you're going to go plug those x's in and give me individual coordinates. How many x's am I going to plug in? 5. I have 5 x's here, right? You're going to plug in each of these x's, and you're just going to go draw these 5 dots on your graph. That's all you're doing. 5 numbers, 5 dots. Don't connect them with a constant line, because they only want you to draw 5 dots. If they wanted you to draw the solid line, they wouldn't give you options x for x's. They just say graph it. So you'd have to plug in all the numbers you can think of, and then start to plot where that thing's going. But they're only giving you 5 dots to go. So when you graph this, and you plug in all of your x's one at a time into there, so -3 squared, that's 9, times 3 is 27. -3 is 24, -1 is 23. So this is 23. Obviously, I'm going to give you problems where you can actually graph that. There's your number, right? This ends up being in 23, because that's 27 minus 3 and then minus 1 more. Next one, -2. If I square that, that's 4 plus 3 or times 3, that's 12. 12 minus 2 is 10. Minus 1 more is 9. So I'm plugging the numbers one at a time into all the x's up there, and figuring out what is it spitting out for my answer. This is a function, right? That you have numbers to plug in. Let's say like I plug in the -2 into my function, and you're trying to figure out what is it spitting out. Well, in my case, it's spitting out a 9 on my calculator. Again, you could literally type this in calculators if you know how to type it in. -1, square it. That's 1 times 3 is 3. I'm going to subtract 1, which is 2. Subtract another one, which is 1. I plug in a 0. 0 is 0 minus 1. That's -1. That's plugging the 0 down here. 1, plug in 1 everything. That's gonna be a 3 plus 1, which is 4, minus 1, which is 3. So there you go. And I would go and draw those 5 dots. Does that make sense? I'm pretty sure the first 2 problems in your homework, first 2 or 3 tomorrow, that's what you're getting. So you're gonna have graphic. Now again, you're only drawing 5 dots, and then you're going on to the next graph. Don't connect them with lines, nothing. The next series of like 10 questions, they'll give you a table and ask you a bunch of questions about it. Might be, what is the function? What's the x-intercept for f? What's the y-intercept for f? They could ask for different things if it's on the table that I can identify. Like, when I look at this table, I can definitely see this, the f function, like f function here, it has a y-intercept of 0, 1. 0 right and left, up 1 at the y-intercept. The g function has the same exact y-intercept. In fact, they actually cross at the same spot. These are 2 different graphs, they're actually intersected. They actually intersected later at 3, 10. So they have the same x and y number. That's the idea. Questions at all about our different problems that you're going to have? Now again, tomorrow we're going to review this. I'll go through a couple different examples of each type of homework problem that you're going to have, and then you're going to have time to work. Today after school, I'm gonna go through anything that people have turned in, like a practice guide or whatnot, because we had homework due last week. So I'm gonna enter that in the grade notes. If you're missing like a page 50 or page 65, if you're missing something like that, I'm probably gonna enter it so you can see it on the grade book later today.
Can I go to the office?
Yeah.
Okay, that's a office.
Let's go.
I have to scan another day. Fax. I was really
What? Why is it even here? Why can't I? I don't understand. Hey, well, maybe I'll just scan this in the computer for me. The love handle's really just setting off. The fact that I can see
What is that?
it's boiling up.
No.
The fact that he threatens to bust out at any time.
That
thing cannot-
It made me scared a little bit. I feel like he was definitely afraid of like, kind of have to after that.
So,
What are they?